All right, hey y'all, howdy. I'm going over Unit 11, pages 115 through 116. On every question that you get with a table, I need it to be a point for you to draw arrows. How do you get from one value to the next? Because we need to find the rate, which is always the y, delta y, over x, delta x, the rate of change, that is.
Morgan Taylor and Gregory Jordan to the correlator line. Morgan Taylor and Gregory Jordan to the correlator line.
So the change in y here is a difference of 75 cents. And the change in x here is a difference of 1. So my rate is going to be 75 cents over 1, which is just 75 cents each. Okay? And wherever we see 75 cents each, we know that we need to put that next to a variable. Then the question says, which of the following represents the same relationship between x and y? So I need this table here to match these graphs, equations, and verbal situations. So every point that I run and jump at on my line has to match these points here. If they do match, then they're a part of my answer, and I need to choose the appropriate answer that shows it. If this does match the equation, y equals 3/4 x, then I need to choose that as part of my answer. And if a karate club earning 75 cents for every candy bar or each candy bar sold during the fundraiser, then that needs to be chosen for my answer. Number 2, I'm giving this one to you in Skyward because it's kind of confusing. But it says, look at the equation. It says y equals 12x plus 1. If y represents the total number of cookies, which situation best describes the equation? So y is cookies. Total cookies equals 12 times something plus 1 more cookie. So this is some cookies. And this is 1 more cookie. So if it says y represents the total number of cookies, which situation best describes the equation? This says after purchasing X dozen, well, a dozen is 12 cookies, 1 additional dozen costs $1. This is 1 cookie, not $1. X dozen, additional cookies, X dozen, $1. 1 dozen is free. Remember, a dozen has to do with 12. 1 cookie is free. So we know that this one's wrong. Find the best answer otherwise. And if you don't know it, Skyward will tell you. Number 3. Cameron works for a car dealership and earns a monthly salary of $17.50 plus a commission for every car he sells. $17.50 plus a commission for every car he sells. I don't know what this is, but the commission is my each. Okay, this is my rate of change here. How do I find a rate of change? Well, a change in y over a change in x. How is this changing in relation to this? This is my rise. This is my run. So I'm going to take 42.50 minus 22.50. Oops, that should be a minus, not a divided by. And I'm going to get a number. That's what I'm adding here. Then I'm going to take 5 minus 1, which is 4. 4 cars. So this is my rate for 4 cars. Rate something every 4 cars. Find it for 1 car, and then that's going to be your coefficient. Remember, your coefficient goes next to the variable. times variable. Be careful here. This number that you get is going to go in this ratio. If you need help calculating, most likely you're watching my video on YouTube. Go to Desmos and do this divided by this, and then it will simplify the fraction for you to give you the per car rate. Number 4, it says nickel is a transition metal. A common application for nickel is coin fabrication. Information about the density of nickel is provided in the graph. So I like to tell you to look for friendly points here. This is not necessarily a friendly point, but it's close to 10. This is not necessarily friendly, not friendly, not friendly. This guy right here is almost right on the button. Friendly point here. I'm not drawing lines up and over either, y'all. I've seen that so many times on your homework. We're not drawing lines here. I know you're trying to guide your pencil to connect here, but once you do that, erase those lines written. And then it's going to be a big rise over a big run, and it's proportional, so that means I only need that rate. Rise goes from here to here, and run goes from here to this number right here. You need to figure out what this number is and then divide your rise by your run. Rise divided by run. Last few questions. Students complete an investigation that tests the effect of different forces and accelerations on a toy cart. Data from each trial of the investigation is shown in the table. Force and acceleration. Force is in newtons, accelerations is in meters per second squared. It says students use the following equation for all calculations. Force, net force equals mass times acceleration. Do not overlook this. This is an equation. Force equals mass times acceleration. If I want to solve for one of these, then I'm going to divide my force by either the mass or the acceleration. So I'm going to take the force and divide it by whatever its acceleration is to get the mass. So divide that, divide those, you will get the mass. You will get the mass, you will get the mass, you will get the mass. The mass should stay the same each time. Once you get that answer here, you're going to put it right here. What is the mass in kilograms of the toy cart used in this experiment? Write your answer in the space provided. Some number of kilograms. Now it says create an equation to represent the line that contains all the data points from each trial. This is the same equation that you're going to write down here. What is the mass? That goes in your equation. When you input this into Skyward, you need to put the whole thing in your answer. Number 7, it says complete the sentence about the line representing net force. Circle the correct answer from the drop-down menu to complete the statement. The line represents a net force. The line that represents the net force shows a linear, either proportional or non-proportional relationship. Remember, if there's no mass, you can probably have no force. Number 2. Two students participate in a race. The starting line is 1 meter in front of the teacher. Okay, we're not starting at 0, we're starting 1 ahead. Hence why my y-intercept is 1. Data collected during the race for both students is shown in the graph. Okay, every time you have a graph, you have 2 lines here. You need to find 2 friendly points and do the rise over the run. There's a friendly point here And there's a friendly point here. Yes, it's in that cabinet over there. Calculate your rise, calculate your run. Rise equals, this is going from 2 to 3. If you have $2 today and $3 tomorrow, how much money did you rise by? Then your run is from 1 to 2. If you have $1 today and $2 tomorrow, how much money did you run by? Then student A will have a rate or rate of change of a rise over run, and it'll be a fraction, and you will simplify that fraction. Student B, I'm going to use this friendly point here, starting at 0 and 1, and then I'm running and rising to this point right here. You start at $1 and you have $1.50 tomorrow. How much did you rise by? You start at 0 and you end up at 1. How much did you run by? Then student B has a rise over run too. You need to simplify these fractions or calculate them. Put them right in your calculator, and these will be your rates of change. So if y equals mx plus b,
Route 1, your bus is here.
This is your starting point. Where did it say we started? And then what are your rates of change? So student A goes here, and student B goes here. Lastly, they want to know, complete the sentence to describe each line in the graph. Circle the correct answer from the drop-down menu to complete the statement. Each line in the graph.
72 and 78, your bus is here. 72 and 78, your bus is here.
Represents a linear, proportional, or non-proportional relationship. You choose. Remember, proportional goes through the origin. Non-proportional does not go through the origin. Good luck.